Welcome back, everyone. This may well be the last video of the semester, so let's go ahead and get started. We're going to pick up where we left off. So we see here we want to compute the arcsine of pi over 3. So which angle, when you plug it into the sine function, gives you an output of pi over 3? Well, that's not usually something we deal with, so let's see if we can kind of figure this out. Let's first make sure it's like actually in our domain. So we scroll up here and we see that the arcsine function, whatever number we plug into the arcsine, needs to be between -1 and 1. But pi over 3, well, we know pi is 3.14159, etc. You divide that by 3, you get a number bigger than 1. So in fact, this is not even a well-defined concept, right? Because no input will ever give you an output, no input into sine will ever give you an output bigger than 1. And so an output of pi over 3 under sine is impossible. And so this is actually, we're not even going to get an equal sign there, it's just undefined, right? Since pi over 3 is bigger than 1, right? And you've kind of seen this before, like when you were solving trig functions in the previous section. Or trig equations, excuse me. Like if you had like sine of whatever equals 2, then there was no solution there, right? Well, this is the same idea, right? You can't plug a number bigger than 1 into arcsine or arccosine. But the other four you can. Just FYI. Okay. Okay. So now here we're combining trig functions here. So let's work inside out. So tangent pi over 4 is 1. And so now we want the arcsine of 1. Well, what angle in quadrants 4 or 1 has sine of that angle equal to 1? Well, that's angle pi over 2, right? Okay, here. Arctangent of minus 1 over root 3. You may also have minus root 3 over 3. I think this is going to be in quadrant 4, this angle. And if I'm not mistaken, it's angle minus pi over 6. Right? Now, these last three are going to be treated a little bit differently, so we'll just keep them all on screen here as best we can. So sometimes when you're mixing trig functions, especially when you have an arc trig function on the inside and then like the same type, so notice secant and arctangent are not of the same type, then you have to do the following. So you definitely don't know what the arctangent of 7 over 4 is. And so what do we call things that we don't know? Well, we give them a variable name, right? And now since the arc trig functions always return to you an angle, what's our preferred notation for an angle? We're going to call it theta, right? So we're going to say, okay, let's let theta equal the arctan of 7 over 4. All right, so we're actually going to get rid of that equal sign. We'll come back to that in the end here. All right, so really what we're trying to find is we want to find, well, if we're calling the inside part here theta, what we're really trying to find here is the secant of theta, right? Okay, so let's see what we can do. Well, let's actually use this starred property way up above that we have. Trig of arc trig of any input always equals that input. So if theta is equal to the arctangent of 7 over 4, then I know that the tangent of theta, well, that's the tangent of the arctan of 7 over 4, which has to equal 7 over 4, right? Because I have, the order is correct, right? It's tangent of arctangent. And that always cancels to give you just the inside. All right, well, now I know what the tangent of theta is. I'm trying to find the secant of theta, so use a Pythagorean identity. I know that the secant squared of theta is 1 plus tangent squared theta. And so that tells me that the secant squared of theta is 1 plus 7 over 4 squared, which is 65, well, 1 plus 49 over 16, which is 65 over 16. And so therefore, I know that the secant of theta is, well, it is the square root of that, but it could be positive or negative, right? So we need one more piece of information. Because tangent of theta is positive, theta must be in quadrant 1, right? Because arctan, which is theta, arctan of 7 over 4, always returns an angle in quadrant 1 or 4. Well, since the tangent of that angle is positive, theta must be in quadrant 1, right? And so in quadrant 1, the secant is also positive. So in fact, it's going to be the positive one of these. So secant of theta is going to be the square root of 65. And then we can take the square root of 16, which is just 4. So it's the positive one of those. And that's what we were trying to find, right? Okay, so I get that this maybe seems a little bit strange. So let's try another example. All right, so these aren't of the same type. And we have an arc trig on the inside. So we're going to call this theta. So we're going to let theta equal arc sine minus 2/5. Then we know, well, what we want is we want the cotangent of theta, right? But what we know is that the sine of theta is minus 2/5, right? Because sine of theta is sine of arc sine, and that cancels to always give you the inside part. So where must theta be? Well, remember, arc sine returns an angle in either quadrant 1 or 4. Well, since the sine of that angle is negative, it must be in quadrant 4. All right. So I have sine of theta. I need cotangent. So, pick your favorite Pythagorean identity. But I'm going to say, okay, since sine of theta is minus 2/5, the cosecant of theta is minus 5 over 2. And I have a Pythagorean identity now that says that the cosecant squared theta is 1 plus cotangent squared theta. And so minus 5 over 2 parentheses squared equals 1 plus cotangent squared theta. So that says that cotangent squared theta is 25 over 4 minus 1, which is 21 over 4. And so now the cotangent of theta is plus or minus the square root of 21 over 4. But now that's root 21 over 2. But now, do we need a positive or a negative? Well, in quadrant 4, which is where theta is, cotangent is negative. Right? That's what we were trying to find. Okay, one last example. So go ahead and pause the video and try it on your own if you like. But we're going to go ahead and get started on it here. Now, here's cosine is a little bit different. Arc cosine returns angles in quadrant 1 or 2. And now, since the cosine of theta is negative, it must be, the theta itself must be in quadrant 2. Okay. All right, so I have cosine theta. I need tangent theta. So use a Pythagorean identity, any of the three that you like. But I'm going to kind of do the same thing I did last time. I'm going to say, okay, the secant of theta is minus 3 over 2, since I know cosine theta is minus 2/3. And now I'm going to use the Pythagorean identity that secant squared theta is 1 plus tangent squared theta. Okay, so we get here, and we see that the tangent of theta is plus or minus square root quantity 5 over 4, which reduces to root 5 divided by 2. And now we need to know if we have a plus or a minus here. Well, since theta is in quadrant 2, the tangent of theta is going to be negative, right? And so we get a negative answer. And that's what we were looking for, right? If we're calling this arc cosine of minus 2/3 theta, we wanted to find tangent of theta, which is what we did. Okay, so there's a few examples, easier ones like above in the last video, and then some complicated examples like these on the worksheet. But I think this is the final video for the semester.